In this video, we are going to have a look at the Arduino serial plotter. Now, up to now, we've used the serial monitor. Now, the serial monitor is essentially a little text editor type window. When we transmit information off the Arduino, we do the serial.print command, and that actually sends ASCII text over the USB cable into the PC. We open up the serial monitor, and that just displays that ASCII text as it comes off the Arduino. So if we write in certain characters and numbers and things like that, that is exactly what would appear on the serial monitor. Now that can be very useful for simple functionality. So for example, we can send initializing, and then when it completes initializing, or if it does certain steps and things like that in the form of text, so that we can follow the process that the Arduino is going through, and we can actually spot if it doesn't transmit certain bits of data, if it isn't entering bits of code that we're expecting it to do. So it's quite a useful debug tool. Now, the limitation comes in if we actually have sensor data coming in the form of numeric values. Okay, we can actually look at these numeric values and we can see the patterns change as it transmits to that serial monitor, but it's not the best visualization tool. What we could actually use to visualize this data is what we call the serial plotter. Now, the serial plotter uses the same data that has been transmitted into the serial monitor. So the serial data is still coming off the Arduino, down the USB cable into the PC. But what the serial plotter tries to do is it tries to pass through the data that is received and essentially pull the numbers out. When it pulls those numbers out, it can then show it in the form of a graph on the serial plotter. So it's exactly the same data. We might have to format that data in a certain way in order to get it to work more cleanly with the serial plotter, but it will effectively attempt to pass that data no matter what we transmit. Obviously, if we don't transmit the right data, it won't show anything. If we transmit random bits of data, it might show random stuff on the serial plotter. So if you're getting random data on the serial plotter, it's probably just not in the right format. It just simply cannot pass the text that you're sending. So in this video, we will have a look at what we can send and how it will decode that data. Now, the other important thing to understand with the serial plotter is we can actually plot multiple what are called data sets. So essentially, it's going to show multiple lines. In the case of the example today, we're going to be talking about the Wizibot and the line sensing. Now, the line sensor is effectively a reflectance sensor. So the stronger the reflectance off the surface of the desk, the stronger the signal that will be received by the sensor. Okay, so we should see higher numbers when it's getting lots of reflectance and lower numbers when it's getting less reflectance. Now, if we look at that, we've got a left sensor and a right sensor. And so what we can actually do with the serial plotter is we can plot two data sets, one for the left and one for the right. If you look at the right-hand example there, that is the serial plotter window. We'll have a closer look at that in a second. But you will see that we have a blue line that's representing the left sensor data, and we have a red line that's representing the right sensor data. So we can actually transmit multiple data sets. It's probably limited to something like 8, something like that. But essentially, we can transmit as many as we want. As long as we format it in the correct format, it will show the data and it will visualize that data for us. If we have a look at the window that makes up the serial plotter, we'll just do a quick breakdown of what's on that window. In the top left there, you will see the key that represents the data. Okay, so essentially that's the key for your data lines. You'll see that the blue line is labeled as left and the red line is labeled as right. Now you'll also notice there's little checkboxes next to those. We can enable or disable the drawing of those lines. So if you ever want to just isolate down to a single channel, you can uncheck all the other channels and it will just show that one channel for you. The data coming off the Arduino is exactly the same as it was before. We don't have to change the code. Okay, it's just the serial plotter will not render the other lines that we uncheck, so it won't show them on screen. On the bottom there, we then have the time axis. Now this at the moment is represented by each bit of data as it comes in. So the 12,857, that's the 12,857th bit of data that came in for those two data sets. Okay. If we hit the clear data button in the top right there, that will clear it all down and it will reset to 0. It will then, for every single data point that it gets, add 1 and so forth and so on, and it will draw the graph. It will draw from the right to the left, and so it should scroll from the right to the left with the latest data showing on the right-hand side. The numbers on going up and down the left-hand side are the values that you've sent through. You will notice that with the serial plotter, when you start to use it, it automatically kind of ranges itself to the highest and lowest data point that it currently has in the data set. Okay, that's effectively what's showing on screen at the moment. This at the moment is only showing the values between 1022 and 1010. If we started to see actual data coming through and those values actually changed, it would automatically scale itself, sort of zooming in and zooming out to better represent the data that it shows. If that ever becomes an issue for you, the best thing to actually do is simply add 2 more data sets. Add a low point data set which just constantly transmits the lowest value that you want to see, and a high point data set that transmits the highest value that you want to see. Essentially, you're going to end up bordering your data sets. Okay, I will show you how to do that in a session if you want me to clarify a bit more. But essentially, just remember this is zooming in and zooming out as you add and remove data, as a result of which sometimes it can look a bit strange as that kind of data constantly seems to fluctuate. Now, the way that the serial plotter actually works is it's receiving the data off the serial port. Okay, now if we transmit simply two numbers, we need to break it down in the following way. The first value needs to come in just as a numeric value. We then need to split it using a special character. We either use the /t, which is the tab, or the comma. Now it's up to you which one you use for this. The serial plotter will split on both of those. The tab can be very useful, obviously, for separating your data out if you wish to also visualize it in the serial monitor. So you see the serial monitor window in the example there. You can see that by putting the tab in there, we put a space between the data, and we can simply, it just helps us visually see it ourselves. The serial plotter will plot that data that you're seeing in there is now being plotted on the serial plotter on the right there. Okay, the serial plotter will simply split on either the /t or the comma, so it doesn't actually care. It just helps. I prefer to use the tab just because it separates it out a bit. Once you put that tab in, you then put the next value in. So value number 2 comes after the tab. And then to end that data plot, we then say new line. So those 2 points will now be rendered onto the graph on the right there. First point will be rendered as the left, which is the blue, and the second point will be rendered as the right, which is the red line. It will then go to the next set of data. It will then plot the first one. Tab will split it. Second one, new line, it will transmit the next line. So it will draw the next bit of data onto that graph. Everything will move towards the left. Okay, so the way in which it's passing, it just needs to know what values it's receiving. It needs to then split that data using that special split character. And then new line tells it, now render it onto the screen. Okay, if we had more values, we'd simply do the first value, comma, second value, comma, third value, comma, fourth value, ending it with a new line. Once we end it with a new line, we then do it again. First value, comma, second value, comma, third value, comma, new line. Okay, and that is how we plot multiple data sets and multiple lines. Each line will get its own set of color. You may need to clear the data when you do a reset because it may sometimes not render the right colors and things like that. Just hit that clear data in the top right corner and it will reallocate all the colors and the keys. Okay. The next thing that we need to look at then is adding these actual key names. So you'll notice on the top right there where the keys are, we've got left and we have right. By default, it will actually show value 1, value 2, value 3, value 4. It doesn't have names by default. We can actually give them names, which can actually help us understand the data that we're seeing. So for example, we have the left and the right sensor on the Wizibot. If we just left that as value 1 and value 2, we'd have to actually try to identify which one is value 1 and which one is value 2. Okay, so by giving it names, it just helps clarify it as we read that data, as we see the data on the screen, as to which sensor it is that we're looking at. In order to add the key values, or the names for these keys, we actually need to include them as part of our serial data. What we actually do is fairly straightforward. We put the name, followed by a colon, followed by the value. We then put the splitter character that we had, so that's /t or comma, and then we put the name of the next channel, the colon, and the value for the second sensor, and then the new line. So you'll see in the example on the bottom left there, we have left colon 1017, that's our first channel, tab right colon 1020, that's our second channel, new line, and then we repeat that process. Okay, so the important thing here is that we can put the name in before the colon, but the colon must be there, otherwise it doesn't know that that's the channel name followed by the data. Okay, so that colon splits the channel name from the data. The other important thing to understand with key names is we cannot include any spaces. Okay, obviously keep your channel names fairly short as well because they've still got to appear on that window. You don't want to start filling up that window just with names. So we keep it simple, left, right. Okay, don't include any spaces. If you include the spaces, it will only show the first word. Essentially, it will split from the space as well, and it may actually confuse the serial plotter itself. So just include a single word, a very short word, just one that helps you understand which channel it is you're looking at. Beyond that, that is the serial plotter, or at least the basics of the serial plotter. Okay, hopefully that helps you understand what it is we're doing, and hopefully in the future when you're doing your own projects, you'll be able to use the serial plotter maybe to visualize the data, maybe to demonstrate in your demos and things like that as to what data is coming off your sensors.